The restoration of a neglected vessel always begins with ruthless elimination. Before any new material can be integrated, years of decay, obsolete wiring, and weathering must be stripped away. Watch how the builder immediately targets the corrupted elements. Tangles of degraded nylon rope and outdated navigational hardware are completely ripped from the fiberglass hull. The captain's chair, secured by rusted fasteners, is unbolted from its pedestal to expose the stained, weathered teak decking beneath it. This initial phase is entirely about establishing a clean baseline. An old Garmin dome antenna is unscrewed, and its coaxial cables are pulled through the bulkheads. With the bulky hardware removed, the focus shifts to surface decontamination. A heavy application of alkaline foaming detergent is sprayed across the stern. This thick foam clings to the porous teak and oxidized gelcoat, chemically breaking down embedded salt, algae, and organic buildup. Using a stiff bristled deck brush, the builder aggressively scrubs the wood grain, lifting decades of embedded grime before power washing the slurry over the transom. The high-pressure water physically ejects the loosened debris, revealing the true condition of the timber and fiberglass below. Once the exterior is neutralized, the boat is loaded onto a heavy-duty roller trailer and transported inside a climate-controlled garage. The transition indoors is critical. Fiberglass repair, epoxy application, and marine painting require strict temperature and humidity controls to cure properly. With the hull completely stabilized in a dry environment, the real structural recovery can commence. The first target is the hull's damaged underbelly, demanding intense mechanical precision and heavy abrasion. Beneath the waterline, the hull is coated in layers of failing anti-fouling paint. This ablative coating is designed to slowly wear away in salt water to prevent barnacle growth. But over years of neglect, it flakes and blisters, creating severe hydrodynamic drag. The builder initiates the removal process using a high RPM Makita impact driver fitted with a heavy-duty abrasive wire wheel. The rotational friction obliterates the compromised top layer, generating a cloud of toxic marine dust. Transitioning underneath the trailer, the removal becomes intensely physical. Working on a mechanic's creeper, the builder utilizes a hardened steel hand scraper to manually peel the stubborn turquoise paint from the fiberglass strakes. Each stroke requires significant lateral force to shear the chemical bond without gouging the underlying gel coat. The scraping reveals a chaotic patchwork of old primer and raw fiberglass. Notice the specific angle of the blade, maintained at a shallow 30 degrees to maximize lifting power, while preventing accidental substrate damage. A pressure washer is brought back to blast away the residual dust, providing a stark visual of the remaining defects. Deep abrasions and impact gouges from submerged rocks are now entirely exposed along the keel. These voids compromise the structural integrity and fluid dynamics of the hull. To restore the smooth hydrodynamic profile, the builder mixes a highly resilient two-part marine epoxy filler. Using a flexible plastic spreader, the viscous compound is forcefully pressed into the damaged cavities. The flexible blade contours directly to the curved geometry of the hull, ensuring the resin completely fills the void without leaving any hidden internal air pockets behind. Once the marine epoxy achieves full chemical cure, it forms a dense, waterproof matrix that is significantly harder than the original fiberglass. The builder utilizes an orbital sander equipped with extremely sharp aluminum oxide paper to level the cured patches. The orbital motion aggressively flattens the convex filler until it sits perfectly flush with the surrounding hull. With the surface structurally restored and flattened, absolute precision is required for the new waterline. A continuous length of high-adhesion marine masking tape is stretched precisely along the chine. Next, the builder prepares a high-build epoxy barrier coat. This specialized gray primer is formulated with interlocking microscopic solids that create an impenetrable moisture shield, preventing water molecules from penetrating the porous fiberglass. The high-viscosity fluid is mechanically agitated with a drill mixer to ensure uniform suspension. Using a high-density foam roller, the primer is methodically applied along the lower strakes. The foam roller ensures a consistent, even film thickness, which is crucial for maintaining optimal hydrodynamic efficiency. Before the primer fully cures, the primary anti-fouling layer is prepared. A heavy, dark blue, self-polishing copolymer paint is poured and mixed. This specialized coating is designed to constantly renew its surface through water friction, preventing marine organisms from anchoring to the hull. The builder applies this dense blue layer directly over the tacky gray primer, ensuring a maximum chemical bond between the two coats. The transformation of the hull profile is immediate and striking. With the exterior protected, the focus shifts inward. The neglected teak decking requires extreme mechanical resurfacing to eliminate decades of deep cellular oxidation. Applying the self-polishing blue copolymer paint requires continuous, aggressive rolling to prevent the dense solids from sagging before the solvent flashes off. The builder lays down this final ablative barrier directly over the tacky gray primer, ensuring a maximum chemical crosslink between the two synthetic layers. This extremely dark blue anti-fouling matrix will constantly abrade in the water, chemically repelling marine growth to maintain peak hydrodynamics. With the external hull fully armored, the focus shifts inward to the deteriorated interior. The boat's teak decking requires extreme mechanical resurfacing to eliminate decades of deep cellular oxidation. Teak is a remarkably dense tropical hardwood, naturally loaded with silica and oils that resist rot, but continuous ultraviolet radiation destroys its surface cellulose, turning it the extremely dull, dead, chalky silver. The builder attacks the flat deck panels with a high oscillation palm sander. The abrasive pads effortlessly grind away the dead wood fibers, instantly exposing the vibrant, unweathered heartwood locked beneath. However, flat surface sanding is entirely insufficient for a true marine restoration. The black, elastomeric caulking lines between the individual planks have chemically degraded, losing their flexibility and failing to prevent water ingress. Using a high-speed angle grinder fitted with a customized milling disc, the builder painstakingly routs out the hardened, compromised sealant from the narrow channels. This high-velocity extraction requires surgical physical control. A single microscopic slip of the rapidly spinning, diamond-edged blade would irreparably gouge the expensive timber, permanently destroying the linear aesthetic appearance of the deck. The precise removal of this old caulk is absolutely critical for long-term structural waterproofing. Following the aggressive mechanical rooting of the deck seams, a heavy-duty industrial wet vacuum is deployed to extract the dense accumulation of toxic rubber, particulates, and sawdust from the newly milled grooves. Every microscopic particle must be eliminated to guarantee absolute adhesion for the incoming marine sealant. Before the internal wood receives its protective coatings, the builder transitions outside to salvage the heavily soiled canvas bimini cover. Spread flat across a wooden deck, the fabric undergoes a high-pressure chemical decontamination. A highly concentrated marine fabric cleaner is sprayed directly into the woven synthetic fibers, chemically breaking down embedded mold, salt crystals, and bird droppings. The builder aggressively scrubs the canvas with a stiff deck brush, forcing the surfactant deep into the weave before obliterating the contaminated slurry with a focused pressure washer stream. Returning to the interior cabin, the meticulously cleaned teak decking is prepared for hydration. The perimeter is carefully masked off with edge-lock tape to protect the white fiberglass. The application of specialized penetrating marine oil commences. Unlike traditional surface polyurethane varnishes that sit on top of the timber and eventually crack under thermal expansion, this proprietary oil is engineered to soak deeply into the microscopic cellular structure of the teak. As the synthetic bristle brush glides across the dry planks, the powerful capillary action of the wood immediately drinks the viscous fluid down. The dull, sanded surface instantly ignites into a rich, deeply saturated mahogany tone. This penetrating oil completely restores the internal moisture barrier, locking out salt water while reviving the timber's natural geometric brilliance. With the teak deeply saturated and protected by the penetrating oil, the structural waterproofing of the deck can be finalized. The builder carefully injects a continuous bead of black marine-grade polyurethane sealant directly into the freshly routed channels between the timber planks. This highly elastomeric compound cures into a flexible synthetic rubber, designed to expand and contract with the wood during extreme temperature fluctuations, while maintaining an absolute watertight seal. The precision of the application is paramount, ensuring no air bubbles are trapped within the deep grooves. Once the sealant achieves its initial tack, the restored teak panels are mechanically fastened back into their original positions on the fiberglass deck using countersunk stainless steel screws, locking the floor matrix solidly in place. The restoration now transitions from structural repair to electronic integration. Upgrading the vessel's audio system requires severe modifications to the existing console architecture. The builder measures and marks a precise circular perimeter on the side of the fiberglass hull. Using a heavy-duty drill equipped with a wide-diameter diamond grit hole saw, the builder initiates the cut. The serrated teeth tear through the thick gelcoat and woven fiberglass backing, generating a heavy shower of white composite dust. This aggressive mechanical extraction creates a perfect geometric void. The exposed internal foam core is manually cleared to accommodate the deep magnetic driver of a new waterproof marine speaker unit. The heavy, vibration-resistant speaker chassis assembly is test-fitted into the cavity. Achieving a flush, airtight mount here is absolutely critical to prevent saltwater spray from penetrating the sensitive internal electrical compartments. Before the marine speaker unit is permanently mounted, the electrical connections demand absolute permanence. Marine environments are notoriously hostile to raw copper, accelerating galvanic corrosion that destroys audio signals. The builder bypasses standard crimp connectors, opting instead to physically solder the heavy-gauge copper wiring directly to the speaker's input terminals. A localized application of thermal heat shrink tubing completely encapsulates the soldered joint, forming an impermeable synthetic barrier against atmospheric salt and moisture. A thick bead of marine sealant is applied to the speaker flange before it is driven into the fiberglass with stainless steel hardware, guaranteeing an acoustic and watertight seal. Moving to the helm, the dashboard requires an even more complex surgical extraction. A rectangular perimeter is meticulously outlined over the faux wood grain console panel. Utilizing a high-frequency oscillating multi-tool, the master builder plunges a fine-tooth plunge blade directly into the rigid composite. The intense vibration effortlessly shears through the dashboard, dropping a perfectly rectangular core to create housing for a modern digital media receiver. The electronic head unit is slotted tightly into the exact cavity and wired directly into the main 12-volt primary ignition harness. Shifting focus back to the exterior hull, the heavily oxidized upper gelcoat undergoes a dramatic aesthetic resurrection. The builder wields a high-torque rotary polisher loaded with an aggressive cutting compound. Applying immense physical pressure, the spinning wool pad generates intense friction, micro-abrasively leveling the microscopic scratches and chalky ultraviolet damage. This intense mechanical polishing instantly forces the dull white fiberglass surface to yield a perfectly flawless, pristine mirror-like gloss reflection. The interior refit continues with the revitalization of the primary seating architecture. The heavy aluminum captain's chair pedestals are severely corroded, compromising both their structural rotation and aesthetic appeal. The master builder aggressively sands the metal shafts to raw alloy before applying a highly durable, dual-stage synthetic enamel spray paint. The vibrant red and bright white pigments bond chemically to the metal, creating a hardened, impact-resistant shell that repels saltwater oxidation. While the pedestals cure, an additional point of access is required in the aft fiberglass bulkhead. Using the oscillating plunge tool, a wide rectangular hatch is violently carved into the rigid stern wall. This critical modification grants direct physical access to the vessel's internal bilge matrix and electrical distribution block. Deep inside this newly exposed compartment, the builder constructs the primary power bank. Two massive, high-capacity absorbent glass matte marine batteries are systematically lowered into the tight fiberglass cavity. These specialized heavy-duty lead-acid power cells are engineered explicitly to withstand intense kinetic shock and violent wave impacts without leaking internal electrolytes. Using heavy-gauge copper battery cables with pure brass terminals, the builder links the twin power cells in a parallel configuration. This specific electrical arrangement doubles the total amperage capacity while maintaining the required 12-volt output, ensuring massive, sustained power delivery for the newly installed digital electronics, ignition systems, and bilge pumps. Heavy-duty woven nylon ratchet straps are aggressively torqued down over the heavy battery casings, physically locking the dense power banks to the hull floor to completely eliminate any dangerous internal movement completely whatsoever. With the electrical grid fully secured, the freshly painted metal seat pedestals are driven into the newly restored teak deck using heavy-gauge lag bolts. The thick, padded captain's chairs are locked onto the rotating mounts, finalizing the complete ergonomic reconstruction of the helm. The fully assembled vessel is then hitched and towed outside, shifting the operational focus entirely to the mechanical propulsion system. The massive, heavy-block Mercury outboard engine requires deep internal fluid and filtration maintenance after prolonged dormancy. The builder unlatches and pulls the heavy aerodynamic cowling off the powerhead, exposing the dense metallic labyrinth of fuel injection rails, high-tension ignition coils, and fluid lines. The primary objective is absolute chemical decontamination. The old degraded inline fuel filter is forcefully unthreaded from the primary fuel manifold using a heavy steel wrench. The raw fuel trapped inside this canister is heavily contaminated with microscopic rust, phase-separated ethanol, and water condensation. Allowing this degraded fluid to breach the modern injection system would cause catastrophic engine failure. To ensure the internal fuel lines are completely purged, the builder connects a specialized pneumatic hand pump extraction tool directly to the primary fuel intake valve. Pumping the heavy internal vacuum cylinder, a thick, dark, heavily degraded stream of contaminated fuel is physically siphoned out of the engine block. The toxic, amber-colored fluid is rapidly drawn through the transparent synthetic tubing and deposited into an external containment vessel. A brand new high-micron primary fuel filter is tightly threaded into the housing, ensuring flawless, uncontaminated fuel delivery directly to the combustion chambers. Deep inside the lower unit gear case, the internal lubrication has reached the extreme end of its chemical lifespan. The builder removes the lower magnetic drain plug, allowing a thick, viscous stream of dark blue, heavily degraded gear oil to violently pour out into a catch basin. This specific high-viscosity hypoid gear fluid must be purged to eliminate microscopic metal shavings generated by constant, high-torque propeller friction. With the fluids completely drained, the entire lower hydrodynamic torpedo assembly is unbolted and forcefully separated from the main midsection. Dropping this heavy aluminum casting exposes the primary water pump housing. The builder systematically dismantles the top plate, revealing the internal rubber impeller. This star-shaped synthetic rubber turbine is the absolute lifeblood of the engine's thermodynamic survival. Spinning at thousands of revolutions per minute, it violently forces cold seawater up into the hot engine block. The old blades are permanently deformed and chemically brittle from intense friction and heat cycling. A flexible, highly resilient new impeller is heavily greased and compressed into the tight stainless steel housing, guaranteeing massive fluid displacement. With the vital lower unit reassembled and forcefully torqued back onto the main drive shaft, the mechanical overhaul is achieved. The final aesthetic element is the classic wooden steering wheel. Removed from the helm, the heavily oxidized varnish is aggressively stripped away using an oscillating multi-tool. The raw timber is then saturated with a thick, deeply penetrating mahogany wood stain, chemically darkening the grain to precisely match the rich, newly restored teak flooring inside the fully completed cabin structure. The revitalized steering wheel is securely bolted onto the console, finalizing the helm. The heavy hull slices aggressively through the dark ocean water, but true structural perfection demands an even deeper mechanical test.